This is part 3 of section 3.6, and we are now being asked to write the negation of these statements that they've given us. So if I want to negate this, then I am looking for not P or Q. And since we have a not in front of an and or an or, we're going to use De Morgan's law, which says you negate each of these. So not P is P. We flip that over, and not Q. So this has exactly opposite truth value of this. Okay? Now this one is going to be a multi-step because I have more than one connective here. So I am looking for, if I want to negate it, not P or Q and R. Okay. Now what I want you to do first is just pretend that this isn't even there. It's like just imagine putting a Band-Aid over it, making it look pretty. So what I have here is I'm negating an or statement. So I'm going to change this negative, I keep saying negative, sorry, the not on the outside. I'm going to use De Morgan's law here. So I'm going to have not P, flip this over to and, not Q and R. So I haven't taken care of all of this yet, but I have simplified part of it. Now, if we're supposed to keep doing this, we need to use De Morgan's law right here as well. So I have not P, and I'm still going to keep parentheses, and I have a bad habit of doing that as well. Don't make them A's, they're not. And then keep set of parentheses. This will be not Q or not R. And since I messed it up, let me write it a little bit more clearly. Not P and not Q or not R. Okay. So checking out this one. I again have a conditional, and I need to negate this whole thing. And how do we negate a conditional? You keep the first one and negate the second one. So the negation of all of this would be keep the first one, P, and negate the second one. Not, keep the parentheses, not R or S. And you can see now that we have another De Morgan's law right here. So this is equivalent to P and, I did it again, and I'm going to keep my parentheses, R and not S. Okay. Now the last little bit. In section 3.5, I'm going to bring this back up, what we did last time, and I had marked them with asterisks and things. We were looking to see if these were equivalent statements. And what we looked at is we compared their final truth values all the way down. If they matched up everywhere, they were equivalent. And we did that with these two. Okay? What I've got here are the same two problems. And I'm going to show you an alternate way of figuring out that these are equivalent or not equivalent. If they are equivalent, I should be able to rearrange things a little bit and make them match. Okay? So if I'm looking at these two, and I'm just looking at the patterns, sort of comparing things, here I have a P on the right, here it's on the left. Well, we know of some things that switch the order. So the switching the order of a conditional could be the converse, which is not equivalent, or the contrapositive, which is equivalent. So let's look at those. Do we have either of those? Well, this is a P here, and this is a negative P. So it looks like I did not only switch them, but I did make that negative. So I think I have a contrapositive going on here. Don't be afraid to try something. If you are wrong, you can back up and try something else. You know, you're learning this. You aren't expected to see your pathway all the way through these problems from the very beginning. So what I'm going to do here, though, is let's just take this one, and I'm going to use contrapositive on this. So if I did that, this becomes not P. If not P, then not R, or Q. Now right here, we have De Morgan's rule. So not P, if not P, then R and not Q. Now compare this one to this one. And really the only difference is this has not Q first in front of the R, but you can switch back and forth with and it's no different. It's the same idea as saying 1 plus 3 is 3 plus 1. Okay, so you can see here pretty quickly that they are equivalent if you can see what's going on. And this does take practice. Or you can go through the whole truth table and figure it out. And these were equivalent here. We were able to get them the same here, so these are equivalent as well. And then our last one, and yes, I brought it up here, so we should know that these are not equivalent. But let's just see kind of what's happening. And I'm going to, again, try to figure out how to maybe match some of this stuff. Okay, I see here, I see the P or R. Here I see not P, not R with an and. So I can tell that this is the negation of this one. If I applied De Morgan's rule to this with a negative in front, I'm going to get this part. But look, the Q is also switched. Okay, so let me try working with this one first. And I'm going to try to create this first part. If I make that not P or R, going to, well, if I make that not, I can make that one not as well. But if I not both sides, there should be another not in there, then I'm going to get the Q here, and I'm going to get that here, but is it true? To do this, what did I do? What did I do to this right here? I didn't even flip it. I didn't flip it around. So it's not contrapositive. I kept them in the same order. I just put a not on either one. Well, that's what we do here with the inverse. And we already know that the inverse is not the conditional. So this was inverse. They're inverses of each other. So these are not equivalent. Okay? I can change it into this. It's just a question of whether or not, it's hard to say as a verb, knotting both sides was a legal move or not. And it's not, because it makes it the inverse.